This is a production of Cornell University.
So in 2003, I was invited to Chile to participate in a symposium they were having at the Catholic University of Valparaiso on sustainable ag. And while we were there, they took us on a few side trips, and they showed us these hillside avocado plantings that are kind of unique to Chile. And I was pretty intrigued by the way they're structured and the steepness of the slopes, and really interested in it as a sort of a soil management, ground cover management issue. And I asked Eduardo Ayonadel, who was, some of you remember Eduardo, he got his PhD here about 10 years ago. He's now a professor there. I said, you know, I'd really like to have a student come to Cornell and do a PhD on, related to this hillside avocado production system. And a couple of years went by, and I kind of thought Eduardo had forgotten about this, and then one day I got an email and he said, I think we got just the right student to work on this project, and she'll be applying. So Amaya, Atucha applied. Amaya is from that part of Chile, central Chile, sort of a little inland from Valparaiso, and she got her undergraduate degree at the Catholic University of Valparaiso. And then she worked for a year. When did you get your degree? 2004 or something like that? 2005. Worked for a year with a guy named Francisco Gardiazabal, who's he's kind of the guru of avocado growers. He's a consultant, used to be a professor at university. And we put together a team. It was kind of amazing to be able to do a PhD project from 7,000 or 8,000 miles, however far it is to Chile away, but Amaya was able to do that with a really good support team there. And she also came into an apple ground cover management project that I had started in 1991. And it sort of scared away two previous grad students who looked at the amount of data and the number of years. So we're looking at 16, 17 years worth of cumulative data in this experiment. And Amaya basically just jumped right in on that and did a superb job of summarizing it. She's going to talk a little bit about both the apple soil management project, which is up at the Lansing farm, and the avocado research. And so I guess with no further ado, Amaya, it's yours.
Hey, well, thank you for being here. As Ian said, I'm going to talk about two projects. I'm going to start with a project that we did here in Naples that Ian started in 1991, and then I'm going to talk a little bit about the project that we did down in Chile. So first of all, I just want to start thanking everybody that has helped with this project. It's been a lot of help from people in Chile and here. Without them, none of this would have ever been possible, and also the funding sources.
Sorry, I see Geneva people talking. Maybe I have us on mute. We'll try that.
So the first project that I will be presenting is the long-term effects of ground management systems in a New York apple orchard. The objectives of this study was to determine the impacts of ground cover management system in tree growth, nutrition production, and also in the soil physical and edaphic condition for several years. As Ian said, it started in 1991, and we followed it until 1998. There were 4 treatments: a pre-emergence herbicide that was glyphosate applied twice during the growing season. A pre-emergence that was a residual herbicide that was applied one time during the growing season, and the 4 treatments were only applied on the tree row. All of the drive lanes were kept with grass. A post-emergence that was glyphosate that was applied twice a year, a sod treatment, and a bark mulch treatment. So some of the results after the 16 years, we saw that at the beginning, the treatments with the herbicide were bigger in terms of tree growth. And as the year went by, this trend that we saw at the beginning was what everybody expected, that the trees with herbicides, we're gonna be bigger than the trees with sod because of the competition. We saw that this trend kind of dissipated a little bit, and we saw a huge increase on tree size on the mulch treatment, which was kept during all the following years. And in terms of the trees that were kept bare soiled, that had no competition with weeds or the ground cover, actually we saw that they were much smaller and they grew less than the trees that were with the sod. In 1991, they excavated one tree per plot, and they divided it in sections, and they dried and measured the dry weight of the trees. So what we saw with that data, it's here you can see the below ground parts of the tree, and here's the pre-herb, the post-herb, the sod, and the mulch. This sequence is always the same. It's always going to be the pre first, the post-emergency, the sod, and the mulch for all the graphs. So we didn't see any big difference in below ground. There were no statistical difference, but we saw only on the secondary roots, which were the roots between 1 millimeter to 1 centimeter. And we didn't see any difference above ground. So that was in 1991. That was 9 to 10 years after the trees were planted. In terms of fruit yield, the first years, we saw that the trees on the herbicide tended to have a little bit more fruit than the trees on mulch and sod. But the same as what happened with tree growth, that trend was not sustained over time, and on the last years, we didn't see any significant difference. What happened with the soil? I'm just going to highlight, I know it's a lot of data, but one of the most important things in terms of phosphorus, calcium, we saw that the trees on mulch had much more available nutrients than the trees on the other treatments, and there was not a big difference in 2007. That was from 15 years after. There was not a big difference between the other three treatments. And we also saw some significant difference in manganese and the pH. But one of the most striking difference was in terms of total nitrogen, carbon, and carbon to nitrogen ratio. In 2007, well, in all of the years actually that we measured from 1999 to 2007, mulch treatment had the highest percentage of nitrogen, carbon, and had the highest ratio of carbon to nitrogen. It was significantly different in all of the years. So some of the big conclusions out of this study were that, as I just showed, the difference in soil nitrogen, carbon, and the ratios was much higher in the mulch treatment than in the herbicides and the sod. Another very important conclusion was that everybody expected, and I think that that's most of what you can read in the literature, and that's what makes this study so interesting, is that in the first year, if you have a short-term study on ground management system, you will usually see that the trees that are with herbicide and they have no competition tend to do better than the trees that have a ground cover. But this study shows that that actually is not a trend that sustains over time, and that somehow the trees, not somehow, definitely the trees on the sod treatment are able to compensate for this competition, but the trees that are on bare soil, the deterioration of the soil, the impact that that has over the performance of the tree is much bigger than the competition of the ground cover. And that trees are not able to get over that deterioration of the soil, but they are able to compensate for the competition. And we saw that the post-emergent herbicide, that is the glyphosate treatment that we applied twice during the growing season was a really good combination of weed suppression and soil conservation. So on the same experiment, we decided to come up with a nutrient budget for these different ground management systems. There's a lot of input in terms of herbicides and fertilizers on these orchards to have really good productions. So this definitely has an impact on the environment. And so we thought it was a good idea to do this nutrient budget and figure out where all this fertilizer is going, and also it's a way to optimize our fertilization programs, just to know which are the main pools and what's happening with the different nutrient pools in the soil and in the trees. So the objective, as I say, was to measure and to budget the major inputs and outputs of nitrogen. And we did it in 2 years, 1 year in 2005 with fertilization. We applied 60 kilograms of nitrogen per hectare to the orchard, and we also applied some phosphorus, 25 kilograms per hectare. And then in 2007, it was a year where there was no fertilizer at all. So we could compare what happens when we fertilize and we don't fertilize the orchard. So how did we construct it? The budget, we measure the inputs as the fertilization. In the case of mulch, we also measure how much was being mineralized from the mulch itself. We measure what was going in the amounts of nitrogen in the irrigation and the precipitation water. And, well, as I said, the bark mulch. In terms of internal fluxes, we measure the amount of nitrogen that was being recycled from the surface vegetation. And for that, we had a study on litter bags, litter decomposition study. We sample from underneath the trees, everything that was there. We sample apple leaves and falling immature fruits and the surface vegetation. We had a number of bags with this combination of litter that we previously measured the amount of nitrogen it had, and we took it out in different times, and we measured how much of it was being mineralized and how much was left. And that's how we calculated the amount of nitrogen that's being recycling from the surface vegetation. Then we measure the amount of nitrogen recycling from the leaves, and for that we wrap one entire tree per plot. We collected all the leaves, we took a sample, we dry them, and we analyze it for the content of nitrogen. And we did the same. We took a sample of prune wood, and we also dried and analyzed it for the total nitrogen. And for the soil mineralization, we calculated the soil mineralization based on the potential mineralizable nitrogen. For that, we had a soil incubation study, and then we corrected for the temperature and the soil moisture that we were continuously measuring in this experiment. For the outputs, we measure how much nitrogen was being extracted from the fruit. So we harvest everything. We took a couple of samples of the fruit, and we analyzed it for total nitrogen, and we back calculated the amount of nitrogen. And we also measure the amount of nitrogen exiting the orchards through surface leaching. For that, each plot was hydrologically isolated, and we had a system in which there were drain pipes installed underneath. This happened when the experiment was established in 1991. So all of these pipes would collect water and go to underground extension, and there we had some tipping buckets that would measure the flow, and we would extract a sample of water every time we had an event, a rainfall event or irrigation. and we would analyze that for nitrogen. So we had the volume and the concentration of nitrogen, so we could back calculate how much nitrogen was exiting through leaching. And a very similar way to calculate runoff. Here we have this underground catchment extension where we would had the tipping buckets with a data logger to measure the flow, and then the water would drain into these pipes and go into the tipping buckets. So what are some of the results? In terms of the litter bag decomposition study, we saw in 2005 that the amount of nitrogen being mineralized from the surface vegetation in the mulch treatment, which was much higher than on the other 3 treatments. And also, if you compare 2005 to 2007, this is the year with fertilizer and this is the year without fertilizer, we saw that the amount of nitrogen that was mineralized out of the surface biomass was much higher, probably due to a higher level of nitrogen and a lower carbon to nitrogen ratio. And in 2007, we didn't see much difference between the treatment, though mulch was also higher than the other 3 treatments. In terms of nitrogen concentration in the runoff and the leachate samples collected in 2005 and 2007, in the runoff, the nitrogen concentration was higher for the pre-herb treatment in 2005, and we didn't see any difference in 2007. And in terms of leachate, we saw that actually the mulch treatment tended to have higher leachate concentration of nitrogens and lower runoff concentration of nitrogen. And we saw that in 2005 that the sod treatment also had a higher nitrogen concentration. In terms of water flow, the volume of water that was exiting the orchard, one of the surprising observations is that mulch, as I said, tended to hire lower volumes of runoff but higher volumes of leachate, and that's probably due to all the effect that the mulch has on the soil physical property, the improvement of the bulk density and the macroporosity, which encourage the infiltration of the water, and that's why we had more leachate than runoff. So the final budget. Here are the 4 treatments. The first column for all the treatments is 2005, the year with fertilizer, and the second one is 2007, the year without fertilizer. So the external inputs, the most significant number is in terms of the amount of nitrogen that's being input through the mulch mineralization, was pretty high for 2005. That was a year with fertilizer, a little bit lower in 2007. In terms of internal fluxes, the sod and the mulch treatment had higher values for both years than the herbicide treatments. And overall, you can see that the sod and the mulch treatment had positive balance for both years. Not for the 2 herbicides treatment, they were only positive for 2005, the year with fertilizer, and they were deficient in nitrogen for the year without fertilizer. And probably that is due to the very low internal fluxes, because there's less nitrogen that is being recycled compared with the sod and the mulch treatment. So some of the highlights: the soil nitrogen mineralization and recycle of the ground cover biomass accounted for over 60% of the internal fluxes for both years. So that is, it's pretty high. It's 60% of the nitrogen is being recycled. The fruit accounted for over 70% of the nitrogen that's being exported, most of the nitrogen losses were through leaching rather than runoff, regardless of the ground management system. And as I said, there were a positive balance for nitrogen supply in the sod and in the mulch treatment for both years. And as I explained, the mulch treatment had a higher infiltration, so there was a higher volume of water, leachate water, and also it had higher concentration of nitrogen because of the mineralization, the big input of nitrogen coming from the mineralization of the mulch. So that could eventually, if you keep adding and adding mulch, that could have a potential problem with contamination. And due to that, we decided to, at the beginning, the mulch was renewed every 2 years, but after we saw this really high increase in organic matter and total nitrogen in the soil, we started renewing the mulch every 4 to 5 years. So that was, that's interesting, especially for organic orchards that have all of their nitrogen input through compost or biomass mulch. And as I said, well, the 2 herbicide treatments were deficient in nitrogen for the year without fertilizer because of the very low internal inputs.
A question.
Yeah.
Did you say at the beginning if the mulch treatment was applied every year or periodically?
Was applied from 1992 until 2002. It was applied every 2 years.
Okay.
And then it changed to between 4 and even 5 years.
Yeah.
Because of the really high input of nitrogen.
So neat that it could have that dramatic an effect even at the end with only every 4
Yes,
or 5 years.
because the organic matter and the nitrogen is already accumulated and linked to the high organic matter in the soil. So it just stays there. And also a big difference with the next study that I will be showing is that this soil in general have high organic matter naturally. So you put more and you really build up really fast. So then in 2008, we started this study down in Chile on the impact of ground cover management system on erosion and runoff on avocado hillside orchards. A little bit of background. I know that most of you are not familiar with avocados, but Chile is the top exporter of avocado in the world. And as it happens almost in every place where it's nice weather and it's a beautiful area, everybody wants to live in that area. So what happens? We have this valley, which really, really nice and rich soils where you want to grow fruit, but the city starts expanding and people want to have their second house there to go to the weekends. So the growers decided to sell because it's a good business, and they said, well, what do we do? Well, let's go to the hillsides. It's cheaper. They have the technology to do it. And in the case of avocado, to set up this hillside, it has a number of advantages in terms of the production. Avocado is a very clean crop in Chile because of the weather conditions. We only have rain during the winter. We have 4 to 5 months of rain, and the rest of the year is dry. So there's not many applications to remove fungicides or any herbicides that you have to do with the avocados. So if you set them up in the hillsides, you can have a really good crop and really fast, because also the temperatures on the hillsides tend to be a little bit higher, maybe 1 or 2 degrees compared with the valley. And the biggest problem in this area where they grow avocados in Chile is that it gets a little bit cold during winter. So by just going to the hillside, you can escape this cold damage. And that is, I mean, it's very important for growers because that definitely is, they're playing with having or not having any production, any crop. So what they do is they clean these hillsides. They take away all the native vegetations, and they gather all the soils with an excavator, and they build this sort of like raising beds that we call berms. And then they plant the trees on top of the berms here. And they do this because they think that they need at least a meter of free soil for the avocado root system to develop properly. And if they would not have this amount of soil, I mean, the avocados would not do as well. So that's what they do the first year. They clean everything, they build these berms, and then the next year they set up the trees. So we decided to go down there and to try to compare different soil management systems to see what's happening with erosion and the runoff. And we also wanted to see what was going on with nutrient losses, with the herbicides residue that are going through this runoff water, and what is the effect of the ground cover management on the tree growth, the production. We also observe root growth and the soil physical conditions. So we had 3 treatments. Bare soil treatment, that was a combination of terbiculazine and glyphosate that we applied once a year. We had a ground cover treatment that was a mixture of ryegrass and a native legume and some native annual grasses that was established in the entire area. When I mean the entire area, I mean where the trees are planted, the tree rows, and since these are 2 raised bed, it's the area between the ditches, in the ditch area between the 2 berms and on top. So it's everything has ground cover, and then a vegetation strip, which is only the area in between the 2 berms. So in 2008, as I said, we went down there and we set up 15 of these water catchment stations that consisted of a weir. We would catch all the runoff water coming from this section, and it would drain it into this barrel. And once the barrel was full of water and sediment, it would drain into this little tipping bucket that was attached to a logger, and that logger would record all the water flow, and we could back calculate. And this is how they looked after we left in 2008. We had, the ground cover was just starting to grow. Unfortunately, this is a lot of work, as you can imagine. We built 15 of these, and it's very steep. It's 50% slope. So we were not able to have all the treatments established before the end of the rainy season. So some of the data that we collected for 2008 is a baseline, because the treatment were not established, but still we were able to gather data and to see what happens, what the growers would normally do, because they would keep it completely free, and even sometimes they wait 1 or 2 years before they prepare the sites for planting the trees. So that was interesting data, just to see what happens when you just prepare the soil and you leave those berms just there, exposed to all the different erosion agents. So in 2010, this is how the treatment looked. On the top left, you see the ground cover treatment, and you see that the trees in the ground cover, you see the small trees here. Well, those are replants, because we didn't foresee that we were going to have problems with rabbits and hares. And they decided that the ground covers were an excellent area to have their little nest and eat our tender and nice avocado trees. So we had some replants, and then on your right side, on top right, you see the vegetative strip. It's clean on top, and then you see the ground cover in the ditch area, and on the bottom is the bare soil treatment. You can already see a big difference. The bare soil trees are much bigger and homogeneous compared to the ground cover treatments. So some results, we measure the trunk cross-sectional area for 4 years, and we saw already by the 2nd year that the ground cover treatment was smaller than the herbicide treatments, and that trend was sustained for the next 2 years. So by 2011, both treatments with ground cover had smaller trees than the bare soil treatment, which was very similar to what we saw in the apple experiment, if you remember those results from before. In terms of yield, we have only recorded 1 year of yield. This is the first important yield. It was, those trees have 3 years. And we saw that the bare soil treatment had higher number of fruit and more kilograms of fruit per tree, but there's no difference between the tree size, which is important because the price of the avocado is given not by the kilograms, but more for the fruit size. So you might have less kilos, but if you have big fruit, that's where you make money. So it's interesting that even though there's difference in the number of fruits and the kilograms, there's no difference in fruit size, and that is it's a pretty good size for avocados. In terms of soil nutrient concentrations, I know there's a lot of data here, but I'll just go to the most important part. What we did, we had here, this is a repeated measurement model, so we measured the same, all of the nutrients each year, and then we analyzed it all together for the 3 years. And we've seen some interesting results in phosphorus, calcium, and magnesium. You see that this column represents the ground cover, this is the vegetative strip, and this is the bare soil. So we saw that actually the ground cover had higher phosphorus and potassium than the vegetative strip and in potassium of both herbicide treatments. And we saw some difference, significant difference in the pH. The pH in the ground cover tended to be a little bit higher than on the other two treatments, and a very significant difference between the 3 treatments in terms of organic matter, higher in the ground cover, followed by the vegetative strip, and then the lowest organic matter percentage in the bare soil. And then in terms of total carbon, nitrogen, and carbon to nitrogen ratio, we also saw a very significant difference between the 3 treatments, and the ground cover had higher carbon and nitrogen content than the bare soil. In terms of soil physical conditions, we measured the bulk density, and I'm going to explain this graph because they're all the same, the 3 more like this. So we have here the treatments, the bare soil, the vegetative strip, and the ground cover. And the blue column is 2009. The the red one is 2010, and then the green one is 2011. So overall, for the 3 years, the bulk density on the bare soil treatment was higher than on the ground cover, and there was no difference between the bare soil and the vegetative strip, and neither was between the ground cover and the vegetative strip. So it was like in between both of them. And then you can see that the soil bulk density tends to go up on the second year a little bit. Remember that this is it's not real soil. This is the soil that has been put up together in the sperm. So it naturally tends to compact because it's very loose and fluffy and nice during the first year. But then you have people walking on top of these sperms, and you have the rain effect. So it tends to compact a little bit. In terms of soil microporosity, we saw that the ground cover treatment over the 3 years that we measured had higher microporosity than the bare soil and the vegetative strip treatment. The soil aggregate stability, the same. The ground cover had also higher aggregate stability than the other 2 treatments. And then, as I said, in 2008, we were not able to measure the effects of the treatments because they were not fully established before the end of the rainy season. But we had this baseline in where we were able to gather data from the 15 plots. We pulled them together, and this is some of the numbers. So we were able to record 3 rainfall events, and the runoff, some of the numbers are pretty high. We have over 30,000 liters of water per hectare. with a 70 millimeter rain, which is very high. It's a big number, and in terms of soil loss, almost 2 tons per hectare. And we expected to see more erosion during the first rainfall events because of the soil was all loose, as I said, but as the rain started compacting the soil, we see this little crust that forms on top in the surface of the soil, and you see more runoff than erosion. So the waterfalls for 2009, we had 5 rainfall events. Unfortunately, I don't know if you're familiar with the Niño and the Niña year. So the Niño year, it's usually 4 to 5 years in which there are heavy rains, and then it follows by a Niña, that it's dry years. So we definitely decided to set up during a Niña year because we didn't have a lot of rainfall events. But even though we didn't have a lot of rain, these numbers are pretty impressive, and only imagine if you would have a Niño year where there will be torrential rainfall. This would be maybe 10 times more. So in 2009, that is the graph on your left, and 2010 is the graph on your right, we saw that the bare soil treatment had higher runoff and was significantly higher than the other 2 treatments. And in 2009, by the fourth and fifth event, we didn't have any runoff anymore on the ground cover treatment. So we only had runoff on the bare soil and the vegetated strip. And then for 2010, we only saw runoff on the bare soil treatments. Both ground cover treatments didn't have any water. There was no runoff at all. In terms of soil loss, also, again, this is 2009 and this is 2010. 2009, we saw that the bare soil was significantly higher than the other 2 treatments, which were not significantly different. And you see here that this axis is broken because we really had very, very high sediments and soil losses in the first event. And the same as it happened with the runoff, of course, there was not any runoff in the last 2 events of 2009 in the ground cover treatment, so we didn't have any runoff. In terms of nutrient loss, the graph here, this shows the amount of inorganic nitrogen losses, the amount of phosphorus losses through the runoff water. Here we have the total nitrogen and the dissolved organic carbon. This line here separates 2009 from 2010. As I said, 2010 we only had water samples from the bare soil. So in 2009 we had higher losses in the bare soil than on the other treatment. Basically, in the inorganic nitrogen and the 4 of them, the phosphorus, the total nitrogen, and dissolved organic carbon, the amount of nutrient loss was significantly higher in the bare soil treatment compared with the other 2 treatments. In terms of herbicide residue, this is just preliminary data. We're still working on this, but we ran some of our samples, and we definitely saw some interesting numbers in terms of the concentration of herbicides in this runoff water. Here are the different dates, start from 2008 until 2010. Here are the concentrations of turbidilicin. That's the residue herbicides that we applied. And this arrow here shows the date in which we applied the herbicide. So here it's in the end of June, the end of July. Then you have here mid-June of 2009, and here at the beginning of August of 2010. And you can see a little bit higher concentrations here of herbicides residue. But as I said, we're still analyzing this data, and most of these are the low range concentration because we already seen some samples that go over 400 parts per million of turbidilicin concentration, which is it's pretty high. and unexpected. We also saw some turbidilicin residues on the ground cover, even though we didn't have any application of the herbicide. But what's interesting is in these big orchards, as you see the picture out here, is a 300-hectare orchard. What they do is before they plant, they apply herbicide with an helicopter. So there's definitely a lot of drift, and that's why we saw some residues on the ground cover treatment, which we didn't expect it. In terms of soil-water content in the soil, we saw some significant difference between the treatments only for the summer months. We observed that the treatments in the ground cover, that's in green, and then in red, the vegetative strip, and in black, the bare soil. We saw that the ground covers tended to have a higher content of water during the summer months. There's not a big difference between the year because this is an irrigated orchard, so there's irrigation during the summer. But as I said, we only saw some significant difference during the summer for the treatment, and that's probably due to temperature difference, because in the bare soil, the soil is completely exposed to the sun, and not the case of the ground covers where it's protected. And on soil temperature, we actually didn't see any difference between the treatments. They're all the same. They all had the same, no significant difference, though you can see that the bare soil tended to be a little bit higher also on the summer months compared with the other two treatments. And that's because, as I said, it's exposed to the soil. We also did some root observation study, which I will not be presented because I don't think we're going to have time. And that is, we're still working on this data. So with that, I'll be more than happy to answer any questions. No, but if you have an excess of soil moisture, you can have some problems with Phytophthora, but it's definitely not the case in these orchards where you have these berms that actually, basically, they drain everything. So that's one of the reasons that they decided to build this berm, just to avoid Phytophthora, which is the biggest problem in terms of disease for avocado in Chile.
And the levels of soil moisture you got with the ground cover are still far below the levels of...
Yes. Yeah, we haven't seen any problems with Phytophthora. The trees look absolutely healthy. Yes.
I saw those orchards once myself down there, and I wondered what is the reason for running the trees vertically up and down the hills?
Well, actually, they try to build terrace or to build the berms on the opposite direction. But if you have a big rainfall event, they break all the way down because the soil is loose in there. So if you put pressure and the water ponds on one of the sides of the berm, it just breaks down. So that's why they do it the other way. And what they're looking for here is the drainage. So this is the best way to do it.
Amaya, what do you think is the sustainability of this orchard system? You have some orchards there that have been in place for some time where you can see
Yes.
some of the adverse effects of soil leaching and so on?
Yes, you can definitely, I mean, it's never been measured. That's why I think this study is important, because it's going to give the first numbers to the environmental effect of these orchards. But you can see some of the orchards, I mean, the soil, with 3 years, you already see the deterioration of the soil. You see after a big rainfall event that the river that runs in the bottom of the valley, it's absolutely brown. So there's big input and contamination of water there, and that's the water that feeds big cities that are around. And you see that some of the trees tend to look tired and they look sick, and then what they do for that is they just keep putting more nitrogen.
So how has the industry responded to your results?
When I went down there and I asked the owner of the orchard, which I'm very thankful to him for letting us do this research there. I told him what we wanted to do. He's like, no. I mean, you basically come to my orchard to say that that I'm contaminated, that I'm doing all these horrible things. I don't want you to do anything here. So after talking with my collaborators, they were very helpful with this. We talked with the grower and told him, you know what's going to happen? Eventually, you're exporting all your fruit, and somebody's going to tell you, we don't want your fruit anymore because look what you're doing to the environment. This is not sustainable. We're not going to buy your fruit anymore. So I told him, if we don't find a way to mitigate this erosion and contamination of the water that is being produced with these orchards, nobody's will want to buy your fruit. So let me try to do this and show you what is the effect, and if we can find a way that you can show people that at least you care about what you're doing.
But your first results indicate that ground cover harbors pests, and that the growth of the avocado in those ground cover fields is not very good.
Well, but that is because we didn't know that, but afterwards we discovered that what we had to do, and they knew that as well, is just to protect the first 50 centimeters of the trees, just put a protection as they do here as well for deer, and I mean, it's not something outrageous, and that's something totally possible and feasible to do. It's not that it means much more extra work. So even though some of the data show that there's less fruit and that we're producing less, well, that was the same results that we saw on the apple experiment. The first year, yeah, we see that the bird soil treatments, the trees on the bird soil plots do much better, but that is not something that is going to be sustained over time. And then probably what we're going to see, because the erosion and the effect of the runoff is going to be much more negative than in the case of the study that we did here, where we didn't have that slope. We're going to see that the trees on the bird soil treatment are going to decline, and the trees on the ground cover treatments are going to stabilize, and they're going to be able to compensate for that competition because we have irrigation and because we fertilize them.
So is the experiment going to be continued on for a while?
Yes, my collaborators down in Chile are very interested in this experiment, and they are replicating it on other orchards. You have a question? Yeah.
So as a management system, would it be better to have a bare soil the first year so that the trees can establish well, and then put the ground cover second, third year?
Yes, but in that case, if you don't, it will be better for the trees, but not for the soil and the erosion, because the first year is where you get the highest volume of sediment losses. So I think that what it would be the best thing to do is that when they prepare the soil, to seed the ground cover right away, even before they put the trees, because that way they are already protecting that soil.
Is there any actual data showing those berms are necessary? As you said, they think they need to have a meter there, but do they actually have to have a meter?
Well, that's what we're looking at into our root data. So that's one of the questions we want to answer, to see how deep those roots go and if they actually cover what they think it is the entire berm, and they go all the way 1 meter deep. Because if that's not the case, well, the smaller the berm, it would mean less erosion as well. Well, I hope you enjoy it.
This has been a production of Cornell University, on the web at cornell.edu.